So hello coders, welcome to my channel, and in this video I'll be explaining the problem longest palindromic subsequence. This is a fairly simple problem and what the problem asks is that I have been given a string triple B A B and I have to return the length of the longest palindromic subsequence. Okay, so it is a fairly easy dynamic programming problem and it can be done in many ways, but I will be using recursion plus memorization way because that is the easiest way to solve any DP problem. So let's understand the problem first. In this case, for example, if the string is uh, the string is triple BAB, okay. So just let me change the color. Triple BAB. So in this case, the longest palindromic subsequence length will be 4, okay, and that will be 4 times B. Okay, so first of all, let's discuss what a palindrome is. So basically, what a subsequence is. You know what you guys already know what a palindrome is. So in case of a subsequence is a continuous set of characters. And you can skip some characters in between. For example, this is a subsequence. B B B A B is a subsequence. B B B is a subsequence. B A B is a subsequence. But BAB, this kind of thing is not a subsequence. So if you are going ahead, you always have to go ahead. Okay. So to make a palindrome, what my approach is going to be is that for example, I'm going to use two pointers, left and right. Okay. So if I see that my left pointer and right pointer characters are same, for example, in this case, the first and the last character are same, it means that okay, whatever my palindrome is going to be, like I have two characters that are equal, so it means that the my palindrome's length is going to be at least 2. Okay, now the remaining problem boils down to the remaining part of the string, that how like what can be the maximum length of this character this string BBA, which can be a palindrome. Okay, so in this case, you will see that again I will be pointing at the last characters BBA, and I see that okay, the first and the last character is not matching. Okay, so now what I have to do is that okay, this cannot be a palindrome. These two characters cannot be a part of a palindrome together. So what I will do is that okay, let's ignore this one for a while and write BB, and then another choice can be, let's ignore this one for a while and see what can be the best palindrome maximum palindrome that I can get from these two strings. Okay, so in this string I again use my left and the right pointers. So my left and the right pointer are matching, so it means that it will be at least for this string the at least length will be 2. Okay, and then the string will be finished, and then I will return 2 from this string. And if I pursue this string, what will happen is that first and the last characters are not matching. Okay, then what I will do is that okay, fair enough, now I have to see that what can be the longest palindrome in, if I ignore this character, then my remaining string can become B, and if I ignore this character, my remaining string can become A. So each character individually is a palindrome. For example, if I write X, the string is equal to X, then it is a palindrome of length 1. Okay, so here since the length of the string is 1, I will return 1 from here and 1 from here. Out of these two, the maximum one is 1, and now I will again return 2. Okay, so what will this 2 do is it will add on to this 2. Okay, so my total length will become 4. So this is the thing. So it can easily be done by using recursion. Okay, so let's code it. So for what I'm going to do is that I'm going to make two pointers, int uh, l is equal to 0, int r is equal to s dot size minus 1. Okay, now what I will do is that I will return my I will make a function called lps that will return my length. So lps will have two parameters, s, l and r. Okay, so int lps string ampersand s. Okay, string ampersand s int L int R. Okay, so this is a dynamic programming problem, because like you have choices in this, like a recursion tree is forming and all this is happening, and plus you have to do some optimization, like you have to find the maximum length. Okay, so whenever these two things come, like you have some choices and you have some optimization, then it becomes you should think about dynamic programming. So in recursion way, you have to, in any recursive function there are two parts of a recursive function, that is the base condition and the choices. Okay, so let's write the base conditions first. So as it is clear from this example that the base condition is what, either the string can become empty or the string can become of one character. Okay, so if L is greater than R, okay, so this means that the string is empty. So for an empty string I should return 0, and if L is equal to R, that means that I have to return 1. That means that the string is of one character. Now what are my choices? So I have two choices. So if SL is equal to SR, then I let's make another variable called int length is equal to 0. That will be the length of the palindromic string. So length is equal to 2 plus LPS of what, S L plus 1 R minus 1. Okay, so as it is clear, so for example in this case, in the initial case, the L was here and the R was here, so the first and the last characters are matching. So L will become L plus 1, R will become R minus 1. It means that now I have to find the LPS of this in this part, that is BBA. Okay, it has become quite messy, but here I think it is clear to you. And what will happen if else, if they are not matching, then the length will become maximum of LPS of S comma L plus 1 comma R comma LPS of S comma L comma R minus 1, and in the end I have to return 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 length. So isn't it super obvious, like what I have written here? So this will give me the code, but this will also give me time limit exceeded, because it is a recursive function, and for a recursive function, like I am making two choices like per function in the worst case, and that will give me a time complexity of 2 raised to power n. So to optimize it, what I am going to do is, like, I am going to make a DP table. So to make a DP table, you have to know how many parameters are changing per recursive call. So in this problem, you see string is not changing per recursive call, but left and right are changing. See, it is becoming L plus 1 and R minus 1 and L plus 1 and R, all sorts of things. So let's make a 2D vector. So vector of vector int dp. Okay, and now I will assign this dp. So dp dot assign sp dot assign looks like hybridization of a carbon atom. dp dot assign what, s dot size comma vector int s dot size comma minus 1. I am assigning it with minus 1 because, like, it will help me track the what sub problems I have solved. Once you have written the recursive code, writing the writing the uh, like optimizing it, memorization is very easy. You have to write only three more lines. The first line is the three four lines. The first line is the making the vector, the second line is assigning, the third line is going to be dplr, so is equal to. So what this does is that like, this table is like a big map, okay, where L and R are unique coordinates, and so that for this unique coordinate you are putting the what putting the value that this coordinate will give. So if you have already solved this problem, dplr is not equal to minus 1, then what will happen is that you just return dplr, and that's the problem for you guys. So after writing the recursive code, how easy it was to memorize it, as compared to the top down way, tabulation way, it is 92%. What happens in tabulation is that, why I don't like tabulation is because you have to, like, think about the beginning. If you see the discussions, for example, this guy really posts nice solutions. So this one is a memoization is very natural, you know what is happening, but in tabulation you'll have to do initialization part, like that is that can also be derived from memoization, but you know it's just easier. So if you have understood the problem, please consider subscribing this channel, and thanks and have a nice day.